Welcome to Arizona State University's University Academic Success Programs. This video will cover the topic Faraday's Law.
What is the significance of Faraday's law?
Faraday's law of induction is a basic law of electromagnetism predicting how a magnetic field will interact with an electric circuit to produce an electromotive force, a phenomenon called electromagnetic induction. It's the fundamental operating principle of transformers, inductors, and many types of electrical motors, generators, and solenoids. Faraday's law states that the induced electromotive force in any closed circuit is equal to the negative of the time rate of change of the magnetic flux enclosed by the circuit.
Can you explain this in a simpler way?
Yes, sure. When the flux phi-b through a wire loop changes, or because the wire loop is moved or deformed, or both, Faraday's law of induction says that the wire loop acquires an EMF, epsilon, defined as the energy available from a unit charge that has traveled once around the wire loop. Faraday's law states that the EMF is also given by the rate of change of the magnetic flux. Epsilon equals to minus d phi b over dt, where epsilon is the electromotive force and phi b is the magnetic flux. The direction of the electromotive force is given by Lenz's law, which states that the direction of the current induced in a conductor by changing magnetic field due to Faraday's law of induction will be such that it will create a magnetic field that opposes the change that produced it. That is why there is a negative sign. For a tightly wound coil of wire composed of n identical turns, each with the same phi b, Faraday's law of induction states that epsilon equals to minus n multiplied by d phi b over dt, where n is the number of turns of wire and phi b is the magnetic flux through a single loop.
Can we do an example to make this more clear?
Yeah, sure. Let's do a problem to make this more clear. Question. A plain circular loop of conducting wire of radius 10 centimeters, which possesses n equals to 15 turns, is placed in an uniform magnetic field. The direction of the magnetic field makes an angle of 30 degrees with respect to the normal direction to the loop. The magnetic field strength is increased at a constant rate from B1 equals to 1 Tesla to B2 equals to 5 Tesla in a time interval of 10 seconds. What is the EMF generated around the loop? If the electrical resistance of the loop is R equals to 15 ohms, what current flows around the loop as the magnetic field is increased? Now, let's go ahead and solve the problem. The area of the loop is A equals to pi r square equals to pi multiplied by 0.1 square equals to 0.0314 square meters. The component of the magnetic field perpendicular to the loop is B perpendicular equals to B cos theta equals to B cos 30 degrees equals to 0.8660 B, where B is the magnetic field strength. Thus, the initial magnetic flux linking the loop is phi B1 equals to n multiplied by A multiplied by B1 cos theta equals to 15 multiplied by 0.0314 multiplied by 1 multiplied by 0.8660 equals to 0.408 Weber. Likewise, the final flux linking the loop is phi B2 equals to n multiplied by A multiplied by B2 multiplied by cos theta equals to 15 multiplied by 0.0314 multiplied by 5 multiplied by 0.8660 equals to 2.039 Weber. Thus, the time rate of change of the flux is d of phi b over dt equals to phi b2 minus phi b1 over the time interval del t equals to 2.039 minus 0.408 over 10 equals to 0.163 Weber per second. Thus, the EMF generated around the loop is epsilon equals to minus d phi b over dt equals to minus 0.163 volts. The direction of the current produced by the EMF is such that it will create a magnetic field that opposes the initial magnetic field. That is the change that produced the EMF. That is why there is a negative sign. Note that, incidentally, that 1 Weber per second is equivalent to 1 volt. Now, according to Ohm's law, the current which flows around the loop in response to the EMF is I equals to epsilon over R equals to 0.163 over 15 equals to 0.011 amperes. This is the magnitude of the current produced by the induced EMF.
Okay, so to sum up, Faraday's law of induction looks at the way changing magnetic fields can cause current to flow in wires. Basically, it is a formula or concept that describes how potential difference, or the voltage difference, is created and how much is created.
Yes, you are correct.